All right, chemistry people, today we're going to do some quick practice here to drive home some of those concepts in that video that we just watched. As you take a quick look here, we're going to classify the following unbalanced reactions. We'll come back and learn about how to balance them later as one of the 5 main types of chemical reactions that we just discussed. All right, we're going to start with numero uno, which is a really good place to start. If you take a look at that first equation, I notice that I've got an element, zinc, by itself, and I've got this compound here, hydrochloric acid. We haven't done acid nomenclature yet, but you will. So we've got an element by itself, we've got a compound. As we look at what happens on the product side, looks like zinc comes in to form a compound with chlorine and H gets kicked to the curb. This is a classic example of a single replacement reaction. Boom. Numero dos. I've got some crazy thing here that I don't know how to name because I haven't taken organic nomenclature yet. The true name of that is propane. Get ready, get excited about AP chemistry. This is some oxygen gas, and I make carbon dioxide and water. This is a combustion reaction. The key things I'm looking for here, or I need to react that sucker with some oxygen. So oxygen needs to be one of my reactants. Remember, you can't burn things without oxygen. Fuel that fire. Feed the fire, feed the flames to form carbon dioxide and water. So these are the 2 products you're looking for in a classic combustion reaction. And although you don't know how to name these things yet, just recognize that typically you'll be working with compounds that are called hydrocarbons that are just carbon and hydrogen. Numero tres. We've got this thing, potassium chlorate. There's some nomenclature for you. Forming KCl, potassium chloride, and oxygen. This is a classic decomposition, because I have one thing breaking down into smaller parts. Boom. Numero 4. Barium chloride plus potassium iodate forms barium iodate and potassium chloride. All sorts of nomenclature going on here. I've got 2 aqueous ionic compounds. I form 2 compounds. One is a solid. This is an example of a double replacement reaction. Specifically, it is a precipitation reaction. Because I am forming a solid from 2 aqueous solutions. Don't automatically think that when you see a solid on the product side that you've got a precipitation reaction. Not the case. But when you've got 2 aqueous solutions, when you start and you end up with a solid, boom, precipitation reaction. You're good to go. Also, recognize sort of just switch partners here. The barium starts with chlorine but ends up with the iodate, which is potassium's original partner there. So double replacement reaction, specifically precipitation. And then lastly, let's take a look at this. We've got carbon plus hydrogen plus oxygen forming C2H6O. This is another organic compound. Looks like it has the formula for ethanol, although that's a solid, which is interesting. At any rate, we don't need to know that for this. We just need to recognize, I've got all of these little things that are coming together to form one thing. So this is a synthesis. We have synthesized. We have combined all of these things together to form one thing. Synthesis, reaction, boom, we're done.